right, so in a question like this is a titration style problem. So you've got a strong acid, hydronium, and we're titrating it with a strong base, sodium hydroxide. So anything with hydroxide is a strong base. What we need to do is underline the information that we're given. So I know the concentration of the sodium hydroxide. Okay, and I also know the volumes of my solutions. So I've got 40 milliliters and 10.3. So my test solution is the hydronium. Okay, my test solution is 40 mils. The sodium hydroxide, after several trials, we find that an average of 10.3 mils was used. So we're writing down what we know, and then we'll determine which ones are known, which ones are unknown. So I know the volume of sodium hydroxide is 10.3 mils, okay, which is equivalent to 0.0103 liters. My concentration is in the units of mole per liter, right? So we can't mix liters and milliliters. They've all got to be the same. Okay, my concentration of sodium hydroxide is 0.220 mole per liter. The hydronium, I know that each time my test sample is 40 mils. So that would be 0.040 liters, 40 milliliters. So this is my known sample. This is my unknown. Okay, so if I know that I'm reacting these on a 1-to-1 ratio, I know that H3O plus and hydroxide are reacting at a 1-to-1 ratio to produce water, right? So that means the number of moles that are reacting are equal. N equals N. From this formula, N equals C times V. Okay, this is in your data books. I can just substitute in C times V for N. Okay, this is the concentration and volume of my known. This is concentration volume of my unknown. So I'm solving for concentration of the unknown. So we're going to sub in 0.220 mole per liter. Okay, and 0.0103. liters. Okay, concentration, I don't know. That's what I'm solving for. And then the volume of my known is 40 mils, or 0.04 liters. So basically, we're just dividing both sides by 0.04 liters. Okay, that'll cancel it over here. And then we divide this side by 0.040 liters. Okay, so type that into your calculator. 0.22, that's my concentration, and then 0.0103. And divide both sides by 0.04. Okay, and we get 0.05665. If you go back to the original question, it says, record your 3-digit answer. Okay, guys, this part of the question tells you that it needs to be in scientific notation, right? Some people put 0.05 or 0.06 as their answer, but it's telling me right here in the question that it's got to be times 10 to the minus 2. So if you go to your answer here, okay, 0.05665, it's got to be in scientific notation, times 10 to the minus 2. So that means you're moving your decimal 2 spaces over. Okay, I'm looking for 3 digits, so 1, 2, 3. Look at the number before and see if you have to round up, which in this case we do. So this should be 5.67 times 10 to the minus 2. The times 10 to the minus 2 is already provided for you, right? It's right here. So you need to fill in your answer sheet as 5.67.